All right, so let's start with the video solution. So today we had weekly contest, and looks like number of solves on A are comparatively less than number of solves on B. So let's start with the video solutions. I hope you have read the questions. I will just give a brief overview of what question is, and then just give the solution and explain how to approach to that solution. I will start from the last problem itself. So in this problem, you are given some conditions on rows and columns. What condition says is that a condition consists of a tuple where A and B. What A and B says is, suppose you have entered a number B in a matrix. So let us say this is a matrix, 3 cross 3, and you have entered a number B in any row. So let's say you entered B here. Then you have to enter A such that A lies above the row of B. So you can add A to this row or add this row. So you can add A in any of the row above. Similarly, the conditions are for the columns as well. So if you add B in this column, say in second one, then you can add A only in the first column. So you can add A in any of the columns which are at the left of the B, and then similarly you can add A to any of the rows which is above the B. So we have to find if there is any possible configuration of such matrix, and if the matrix doesn't exist, we just give print a null matrix. We just return a null matrix. So how to approach this problem? The way I did was a topological sort. So how I came up with a topological sort is, uh, we have a kind of dependencies here that A should be before B. So A should be above B or A should be at the left of B. So I did topological sort independently on rows and columns and just try to find in which row it fits. What I mean by it is, suppose we have, let us talk about the row conditions. So we know that A should be before B. We can write that A is dependent on B, which means A should come before B. It just means this. Similarly, we can have some other conditions as well. Say B should come before C and D should come before B. So like you can have these conditions based on the array you are given in row conditions. Similarly, you can have C can come before E and F can come before E and so on and so forth. So what you can do is you can do just a topological sort. And what can we do using topological sort is you can find the row in which we can assign row to each of the numbers here. So since you can see that the A, D, and F are independent on any of one, so you can just give first row to any of these. So let us say I give the first row to this. Now I have just removed the D from the graph here, and the next one still we have in queue A and F. So I just give row number 2, row number 3, and just remove these. So now all I'm left with B. Then I give a row number 4 here, row number 5 here, and row number 6 here. So this way we just give the row numbers to each of the characters here. Similarly, we can just do in case of columns and assign the column to the values. So just store the rows and corresponding columns to the values. So also, if there's a case there which says that find if the condition none of the conditions satisfy, return an empty matrix. So when the condition won't satisfy is when we have a circular dependency. So suppose A says that I want to be at the left of B, B says that I want to be at the left of C, but C says that I want to be at the left of A. So this is not possible. So in these such conditions where there is a cycle, we just return an empty array. So the way I check the cycle is we are given the k number. So if in the end the row value or column value isn't equal to k, is not equal to k, I make sure that there is a cycle here. Else if there isn't a cycle, then of course we will be assigning every row to this exactly one number at every row. So row value won't be equal to would be equal to k in that case. So I just started k plus 1 in that case. So that was the whole code for this. So first of all, I just built the graph for the rows, did a topological sort on rows, then did the same for the columns and did the topological sort for the column. Meanwhile, I'll just store the rows and columns for corresponding values of I. So for I equal to 1 to k, and then just put the value right there. So this is the topological sort. So first we insert where in degree is 0, and then just calculated the values, assign the row values to each of the number. And in the end, if the row number is equal to k, so this is 0 based actually. The way I explained was 1 based. So if row values has to be from 0 to r minus 1. So if row equals to k, which means we have assigned row to every of the number, which means we return true, else we return false. So this was problem D. Let's move to problem C. So problem C says that there are some places here, I guess. Okay, so there are some I houses here, uh, where each house has some type of garbage value. So G represents some type of garbage, P represents some other type of garbage, and M represents some other type of garbage. And we have three type of trucks for collecting each type of garbage, and we need to find how much time we need to collect all the garbages from all the houses. And we are given the travel time from point 1 to point 2, house I to house I plus 1. So what we can do is, since all the trucks are independent of each other, we can just calculate the time used to collect the garbage, particular type of garbage independently. So you can just calculate the time taken by this type of truck to collect all garbages from all the houses. Similarly, we can independently calculate what is the time taken by to calculate garbage of type P, and similar for type M. So what I did was I just stored the values for the amount of garbage at a particular house of a particular type. So in this case, first case is, let me just write here. So it's G, P, GP, and GG. So you can just say that the for type garbage G, we have one amount here, we have zero amount of garbage G, and here one and then two. Similar for P and for M, we can do that. So for P, we have zero, we have one, one, zero, and for zero, zero, zero. Now we can just independently calculate the amount of time taken by truck to collect this type of garbage, or this type of garbage, and this type of garbage, and add them together to return the final answer. So we are given also a travel time from point I to point I plus 1. So it's 2, 4, 3 in this case, which means that from traveling from initially I added 0 so that I can just calculate the time efficiently, and kind of writing I just thought of writing clean code. So let's just say this is a starting point. Right now I am at the none of the houses, and these are the houses I have, house 1, 2, and 3. So to calculate the time taken from house I to house J is nothing but uh, a prefix of J minus prefix of I. So I just first we just calculate the prefix of it. So the prefix is nothing but 0, 2, 4 to 6, and 9. So in this way, you can just calculate what is the time required for truck to travel from point I to point J. And now you just simulate how it is said that you just go to the first location where there's a garbage. So first you go to this location, find the travel time using this, and then just set the endpoint to be this location, because from the next time whenever you will find a garbage at any other house, you will have to start from this house itself, not from the very initial position that is 0. So you just collect it, then you just move to the next house, collect this, then move to the next house, and then collect it. Similarly, you can do for every other type of garbage. So this is the whole code. So I just calculated each type of garbage, and then just added the answers here. So for a particular type of garbage, I just calculated the prefix value so that I can compute the travel time. Then if there is a garbage, we just add the travel time, and we just add the amount of garbage present there, and then we just update the starting position. And in the end, we just return the answer, the amount of minutes required to calculate this type of garbage. So we just do for every type of garbage, and we just return the answer. So this was problem B. Problem C, sorry. So problem B says that we are given a string, and a string contains some alphabetic characters, lowercase, and star. So what star says that you can just put a backspace and delete the previous character. So this is just a pretty standard problem of stack. So what you do is you just push the characters in stack if they are not a star, and if it's a star, you just pop the top character. So star means just erasing the previous character. So if this is star, you just delete T, so on and so forth. So that's what the easy problem. You just enter everything in the stack, and then just uh, put all the elements of stack into a string and return the string. So this was pretty easy problem. So now to problem A. So problem A says you're given array nums and array query, and you need to find the subsequences that length of subsequence. You need to find the length of subsequence is that the numbers. If we add all the numbers in that subsequence, the sum is less than or equal to query I. So what says is, let's just start from the sample input. So it says 4, 5. This is 2. 2 1. So this is my array and this is query array. So we need to answer each of these queries. So what query 3 says is find the subsequence in this nums in this array such that the sum of all the number is less than or equal to 3. So in this case we just add 2 and 1. So the length is 2. In case of 10 we just add 2 and 1 is 3 and 4. 2 1 and 4. So length would be 3, and in case of 21 we just take all the elements. So answer is 4. So the observation here is since we are interested in length whose sum is less than or equal to query I. So let us say the numbers are a plus b plus c plus d. So let us say there are four numbers, so sum is less than or equal to k. So we need to find the length. So in this case, the answer will be 4. What the you can see that since we are adding the numbers, the order of number doesn't matter. So a plus b plus c plus d is equivalent to, you can just write b plus c plus d, or like number of like any choice you want, the way you want. So the order of number doesn't matter because we are just doing the sum in the end. So if we want the maximum length, we can just greedily choose the smallest numbers. So we just sort the array. So after sorting, the array becomes 1, 2, 4, 5. Now we can just take the smallest numbers until the sum is less than 3 or sum is less than equal to query I. So in this case, we just start taking sum and continue until the sum is less than equal to 3. So answer in this case would be 1 plus 2. For next time, the answer would be, so we have to just calculate the still sum is 10. So 1, 2, 4, and then similar for 21, it's 5. So once we have sorted, I just did a lower bound, which was quite unnecessary, and yeah, I have to fix it too. Other way you can do is you can just, since the n is I guess 1000 in this case, yeah, n is 1000. You can just calculate answer for each of the queries. So you can just say while sum is less than equals to query I, we just start taking the sum. Or what else you can do is you can just calculate the prefix values. So here prefix would be 1, 3, 4, 4 plus 3, 7, and 12. Now you can just answer the query I for like 3 where the index where 3 is, so that's the index. What is the lower bound for 10? So that's the index. You just move to the previous values because this is one is greater, so that's the answer for this. And for 21, so that's the index, but that's still out of the range, so that's the actual index. So you can just calculate the prefix as well. You can just do a binary search, lower bound. You can also do naively. We can just sort the array and find the first the initial prefix whose sum is less than equal to k. So this was all for today's contest. I hope you participated in the contest. I will be making more videos and on topic streams as well as video solutions of the contest. So if you want to join in, stay tuned, and just keep coding. Thank you.